Prior to jumping into the announcement, it's vital to handle the meaning of what we're examining. The Large Hadron Collider, LHC, operated by CERN, stands as a monumental accomplishment in science. Spanning 17 miles, this incredible network of superconducting magnets is not only the largest but also the most powerful particle accelerator on Earth. It is an extraordinary representation of human creativity and scientific achievement. Remarkably, the LHC is so powerful that it has the capacity to recreate conditions similar to those during the universe's birth. But as we explore the vastness of the universe, could this machine, which aims to unlock the secrets of existence, accidentally expose us to more dangerous outcomes? Founded in 1954, CERN is one of the world's most prestigious scientific research institutions. Comprising 23 member nations and a vast community of scientists, it serves as a hub for collaboration and innovation. While the LHC is a flagship project, it is only one component of a vast array of particle accelerators and experiments. Think of it as a racetrack, not for cars or horses, but for subatomic particles racing against each other in a test of speed, precision, and the nature of spacetime itself. At the LHC, protons are accelerated to nearly the speed of light, replicating the energy levels present at the moment of the Big Bang. The resulting collisions produce temperatures far hotter than the core of the Sun. A series of magnets guide the protons along their path, while advanced cooling systems maintain the magnets at temperatures colder than outer space. The collisions are designed to occur at 4 different points around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, capture data. Each detector serves a unique purpose, providing a different perspective on the aftermath of these collisions. Together, they act like massive cameras, capturing the results while scientists sift through the debris to uncover elusive particles, such as the Higgs boson, often referred to as the God particle, and other phenomena that help piece together the building blocks of our universe. By focusing on the subatomic realm, researchers seek insights into the fundamental nature of the universe. However, every new discovery raises even more questions. The LHC is not just a tool. It represents humanity's unrelenting curiosity and thirst for knowledge. It embodies our drive to understand the forces that govern existence. Yet, as we push the boundaries of the unknown, we must confront the ethical and existential challenges that accompany this pursuit. What dangers might arise from delving too deeply into the unknown? Could our quest for knowledge inadvertently open doors to forces beyond our control? At CERN, where the limits of human understanding are tested, a disconcerting realization has emerged, one that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former CERN scientist and a respected voice in the field of particle physics, recently shared a disturbing statement that has both intrigued and alarmed people worldwide. According to Cox, the purpose of the LHC is to recreate a mini Big Bang, a small-scale version of the very event that birthed our universe. Cox also elaborated on the significance of this goal, explaining the immense potential of the LHC for groundbreaking discoveries, such as unraveling the mysteries of dark matter, a mysterious substance that constitutes a significant portion of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly captivating, but it comes with inherent risks. The mini Big Bang is not just a theoretical concept, it is a real phenomenon occurring within the LHC. The collider recreates conditions of extreme heat, pressure, and energy, mimicking those at the dawn of the universe itself. Yet, with such immense power comes great responsibility. What if something goes wrong? This is not a new concern. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that drastically changed his life. While working with the U-70 synchrotron at the Institute for High Energy Physics in Russia, a malfunction caused his head to accidentally cross the path of a proton beam. The beam, traveling at nearly incomprehensible speed, pierced his skull, entering from the back and exiting through his nose. Although Bugorsky experienced a flash of light brighter than 1,000 suns, he remained conscious and even walked to receive treatment. The outcome was both fascinating and troubling. He lost hearing in one ear and suffered partial facial paralysis. Despite the severity of the injury, his cognitive functions remained intact, and he continued his scientific work. Bugorsky's experience serves as a stark reminder of the power and potential danger of particle accelerators. The risks associated with a machine like the LHC should not be taken lightly. There are genuine concerns about unforeseen reactions that could alter the very fabric of existence. Some scientists worry about the possibility of creating a microscopic black hole within the collider. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, destructive forces lurking at the edges of the universe. That the LHC could create even a tiny black hole is both astonishing and terrifying. Could such a black hole eventually grow uncontrollably, consuming the Earth from the inside out? CERN experts have reassured the public that any black hole formed would be incredibly unstable and would vanish almost instantly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC might create a black hole, we must first consider the fundamental workings of a particle accelerator. When protons collide at nearly the speed of light, the energy produced is so immense that it can distort the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the object is heavy enough, it could create a depression so deep that anything nearby would be pulled into it. This simplified analogy offers a glimpse into how the LHC might affect spacetime on a quantum level. At this quantum scale, where the laws of physics appear strange and unpredictable, there is a theory suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC could potentially tap into them, possibly creating a gravitational well that forms a tiny black hole. The possibility of such an event has drawn attention from renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned about the potential for the Higgs boson to become unstable at extremely high energies, which could trigger catastrophic consequences, such as vacuum decay. The respected astrophysicist Sir Martin Rees also raised concerns about the LHC's experiments. In his book On the Future of Humanity, he explored the potential dangers of particle accelerators, highlighting the devastating possibilities of vacuum instability. While he acknowledged that the likelihood of such an event occurring was low, he argued that even a small chance warranted careful consideration. The stakes are enormous, and the margin for error is razor-thin. Scientists at CERN have conducted extensive simulations and experiments, taking every precaution to ensure the safety of their work. Brian Cox himself has addressed the concerns surrounding the LHC, emphasizing that there are stringent safety measures in place. According to Cox, the energies involved in LHC experiments are far less than those that naturally occur in the universe. The chances of creating a stable black hole are astronomically low. Even if one were to form, it would be so small and unstable that it would quickly dissipate, releasing a burst of energy predicted by Hawking's theory of Hawking radiation. Despite these assurances, some have speculated that the LHC's experiments could open a portal to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many, fueling myths and speculation. The concept of creating a doorway to another universe or even to hell has been sensationalized in popular media, amplifying the uncertainty surrounding these experiments. But where did this idea come from, and what does it mean in the context of scientific exploration? The notion of parallel dimensions is not new. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the 4 dimensions we experience, 3 of space and 1 of time. These additional dimensions may be hidden from our senses but could, in theory, be accessed under extreme conditions. Imagine the LHC as a key that unlocks doors to realms that have been concealed since the dawn of time. When protons collide with energies never before witnessed on Earth, they could create ripples or waves that probe these hidden dimensions. While this idea remains speculative, it underscores the allure of the unknown. The possibility of discovering other dimensions continues to fascinate the public, even though mainstream scientists remain unconvinced that the LHC will open a portal to another universe or to hell itself. Nevertheless, the idea of the LHC being a cosmic key unlocking pathways to new realities continues to captivate the imagination of many. So, should we be worried about the risks associated with the LHC? It's easy to get swept up in sensational headlines and fears of a cosmic catastrophe. However, the reality is that scientists at CERN are fully aware of the potential risks. They have taken precautions to ensure that their experiments are conducted safely. The pursuit of knowledge often involves venturing into the unknown, and with that comes a certain degree of risk. The LHC represents humanity's unrelenting curiosity and our desire to understand the universe at its most fundamental level. While the fears surrounding the LHC are not unfounded, They are largely based on speculative scenarios that are extremely unlikely to occur. Furthermore, scientists carry out their work with the greatest persistence. The expected advantages of their examination, for example, opening the secrets of dark matter, finding new particles, and developing a greater understanding of the universe, are genuinely striking. While these accomplishments represent a large leap forward in human knowledge, they come with inherent risks. Like all great advances in science, the LHC's experiments raise significant moral questions. Could the creation of exotic particles or the exploration of high-energy conditions trigger unforeseen ramifications for our planet or for the very fabric of reality? These are questions that cannot be answered lightly, requiring thoughtful consideration of the broader implications of science. All in all, the Large Hadron Collider stands as a testament to human creativity and curiosity. It has already made groundbreaking discoveries in particle physics, shedding light on the mysteries of the universe. Yet, as we venture into these uncharted territories, we must remain vigilant and mindful of the risks involved. The pursuit of knowledge is one of humankind's most ambitious undertakings, but it is not without its challenges. The LHC represents the forefront of scientific exploration, where theory meets experimentation and the very foundations of our understanding of the universe are tested. The journey of discovery is rarely without risk, and the LHC is no exception. It pushes the boundaries of physics, striving to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must acknowledge the profound ethical and existential questions that arise from wielding the forces of the universe. The risks of unforeseen consequences, whether for our planet or for the fabric of spacetime itself, remain a challenge that requires careful reflection. Regardless, the pursuit of knowledge remains one of humankind's most noble endeavors, and the LHC's experiments, while risky, offer a glimpse into the vast unknown realms of science awaiting discovery. As we stand on the edge of revelation, the journey to unlock the mysteries of the universe requires both ambition and caution. The LHC represents the pinnacle of human technological achievement, as well as a powerful tool that has the potential to reshape our understanding of everything, from the smallest particles to the grandest cosmic phenomena. With each breakthrough comes a wave of new questions, opening new avenues of thought and exploration. The journey of scientific discovery, though fraught with uncertainty, holds the promise of insights that could redefine how we see the universe, our place in it, and the very laws that govern it. One of the most significant aspects of the LHC's experiments lies in the intersection of theory and reality. For decades, physicists have grappled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to unify these forces under a single framework, a theory of everything. The LHC has been instrumental in providing insights and experimental evidence that bring us closer to this elusive goal. Its work does not merely advance our understanding of particle physics, but holds the key to uncovering fundamental truths about existence itself. The ethical dilemmas associated with such experiments are significant, though the pursuit of knowledge has always carried risks. But when those risks involve altering the very fabric of reality, the stakes become much higher. Could an experiment at the LHC inadvertently trigger a phenomenon we do not yet understand, leading to consequences that are difficult, if not impossible, to predict? It is a question that scientists, philosophers, and ethicists alike continue to ponder. As we venture into these realms, we must consider the responsibility that comes with wielding such immense power. Yet, despite the potential dangers, few would argue that the pursuit of scientific progress is not worth the risk. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe are immense. The discoveries made by the LHC so far have already transformed the scientific landscape. From the identification of the Higgs boson to advances in our understanding of dark matter, these achievements have far-reaching implications, not just for physics, but for numerous other fields that rely on this fundamental knowledge. As we push the boundaries of what is possible, the LHC serves as a reminder that science is never without its uncertainties. No experiment is entirely without risk, and the LHC, as grand and powerful as it is no exception. But with each risk comes the potential for monumental discoveries. The LHC is a symbol of humankind's relentless pursuit of knowledge, a quest to answer questions that have puzzled us for centuries. In the end, this curiosity drives us forward, the desire to understand the universe, to peer into the depths of space and time, and to uncover the forces that govern everything, from the tiniest particles to the largest galaxies. It fuels scientific progress. The LHC may carry risks, but it also represents the pinnacle of human achievement in the field of particle physics, a tool that allows us to explore the deepest questions of existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for millennia. Whether the LHC will ultimately lead to the discovery of new dimensions, open doors to parallel universes, or trigger unforeseen phenomena, we cannot yet know for certain. What we do know is that it is one of the most powerful tools ever created, capable of revealing secrets about the universe that were once thought to be beyond our reach. The potential for discovery is boundless. As we venture further into the unknown, we are reminded that science is a journey, one that requires both daring and responsibility. Thus, as the experiments at CERN continue, we must remain mindful of the possibilities, the risks, and the incredible potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, also reflects our